Hello, my name is Leah Shobe. I work for AMD, and I would like to talk to you today about what the gaming industry is doing to cause changes in new storage architectures in order to keep up with the demand and the performance for real-time gaming. So we're going to cover a couple of areas today. We're going to give you a gaming overview. I'm going to talk about a little bit about the gaming industry and why it's important to pay attention to this and how big the industry really is. Then I'm going to cover, what we're looking at new storage architectures from the gamer's point of view, and then also talk about the new types of gaming with cloud gaming and how that's having impact on creators and also service providers. So let's get into the introduction here. As you know, I'm sure a lot of you are gamers, gaming is everywhere. When you look at total installations, I mean, we're approaching, a billion installs of all kinds of devices, from PCs to consoles to even mobile devices. Gaming has become a really big deal, and to game anywhere has become a very big deal. Gamers, there are things that they need. They want that edge. They want that competitive edge, that real-time feel. And in order to do that, we've got to look at frame rates and responsiveness and how we stream and how do we have this broad support for all of this. And high quality visuals is extremely important, which of course blows up storage capacities. And we now are forced into looking at, what are some ideas for capacity optimization, because these games have gotten so large. As far as games concerned, their revenue, we're talking about over $35 billion in revenue just from last year alone. So this is a pretty big TAM. I mean, this TAM is larger than a lot of industries that you see in the enterprise. So this is something that folks do have to pay attention to. And esports alone, is now over $1 billion. They're considered a professional sport, just like soccer or anything else that we see. It's pulling in real revenue, and it's a big deal. And it's being backed by the same companies that back, advertising for the NFL and the NBA and other types of professional sports. So this has become a really big deal. And the amount of time that we spend gaming is just phenomenal. I mean, over 1 billion hours every month is dedicated in one way or another, whether you're adult or child, to gaming. This is huge. So that's why we have to talk about how this impacts a storage architecture, because these games are only going to be as real time as the slowest part of the system. And we've had big advances in solid state technology in order to not be the slowest part of a system. But as far as how we handle this data, we still have a little ways to go to keep that real-time experience. So as we look at all of this, and we look at the size of a game, we've gone from just 2 gigabytes. This graph shows soaring up to 150 gigabytes just for one game, for loading one game. There are some games that go up to half a terabyte now. This is huge. This is huge for storage. That means that not only do we have to be fast, but we also have to be able to handle the capacities. Because if you have a workstation and it only has, maybe a terabyte of storage, that's 2 or 3 games. That's not a lot. To be able to store all of these, games that we love to play. So we're going to have to look at two big areas. Well, actually three, but you know, we have to look at the capacity, we have to look at performance, and we have to look at how we optimize all of this. So the big focus that we're going to look at, you know, outside of new storage architectures, a lot of it's going to be centered around loading. You know, load times are the biggest deal in getting a game. How fast can you load and decompress that game? Because that's faster time to play. That also promotes real time, especially if you're doing real time decompression for that game. Cooling is another area that has come up huge for storage for PCIe Gen 4 NVMe. Now we're finding that we're overclocking Gen 4 drives, and the heat and the thermals that we have to consider is just incredible. I mean, now there's special heat sinks for our SSDs. We've had to redesign some systems to be able to handle the cooling flow so that these drives don't overheat. That is extremely important. We will not get too much into the details about cooling. That's a whole nother topic, but I just wanted to bring it up because it does impact storage, and it does impact how we produce our new SSDs to handle this type of performance. And of course, durability. Everybody wants to make sure that, you know, they have good, reliable drives, that they last a long time. So that's something that's also very important, that's considered in the type of media that you put in your gaming system. So I mentioned load times are extremely important. There are some areas that we really need to look at that are really big for loading. Dynamic texture loading. So we have to consider a human focus. You notice when you look at a particular object or look at a particular area in the game, you're going to focus in on that area. It's going to be real high def. You're going to have really good definition. But the way our eyes work, anything around it is going to be you know, less sharp. It's going to be maybe even a little bit blurred, you know, in our peripheral. So we have to keep that in mind as game creators as we design these textures. And dynamic texture loading actually helps to be able to move around with the user. And this takes a lot of talent, and it takes a lot of capacity to do this, not only in memory, but also in storage. We have to be careful of performance degradations, because after a while of doing this, we've got to make sure that, you know, our DRAM doesn't blow up, that now all of a sudden, you know, we're swapping, we're paging. We don't want that to happen, because that impacts performance, that impacts that real-time experience, and we want to make sure that we don't do that. Another area that we need to look at, that we need to make sure of, is error recovery flow. So we want to make sure that the game is reliable, that the game's not going to get stuck, it's reliable, it's going to keep moving. A lot of this can be handled in software, but sometimes we have to ensure that, you know, when a checkpoint happens, you know, an instruction level fault tolerant has an impact. We want to make sure that we're able to recover from that with real-time gaming. So being careful of how we handle error recovery flow is extremely important. Compression is huge in storage, and how we handle compression engines. Making sure that creators are able to have much more intelligent compression algorithms, because, you know, on the other side, that's going to be less work for the user to be able to decompress and be able to play that game. And we also want to make sure that we optimize those data paths. We want to shorten those data paths as much as possible. There's some new technologies out there like computational storage that can offer shortening and optimizing that data path so that we keep that real-time performance going. And effective capacity optimization is also extremely important, and that is something that is very key in how we handle compression. And not only compression on the software side for the game, but how we handle compression algorithms within our storage devices. And so there are some new creations that are coming in around building that in and being able to reduce the footprint as much as possible, because that is extremely important. So new storage architectures that at least I have been seeing in gaming and helping gaming out. One is tiered storage. We've been using tiered storage solutions in the enterprise for decades. It's something that's been around for a very long time, and it tends to be an expensive solution. But now storage companies are figuring out how to do that same type of idea for gaming within just a small M.2 2280 form factor. How can I put it all in that one little space and be able to put the intelligence on there to be able to intelligently move data back and forth between tiers of storage so that you cost optimize and performance optimized at the same time without without it costing large amounts of money. This solution has been extremely expensive for a long time, but people are figuring out how to put it in commodity type sizes, which is extremely exciting. Computational storage is another area, and you may want to check out some of the sessions on computational storage. We have several of them this year, and looking at those, and gaming is a use case for that, especially around compression and decompression. More sophisticated compression algorithms are extremely important, and those are being worked on as we speak. And how do we get those, built into our storage controllers and our storage optimization engines to make that happen? And RAID 10 in your laptop, RAID 10 in your desktop, in your workstation. This is something that is extremely important. Being able to stripe and mirror does add some performance, or just striping, RAID 0. We have found in certain cases where you've been able to double your bandwidth just by doing that. And bandwidth is extremely important in gaming. Bandwidth performance it seems to be a little more critical because of the streaming and loading attributes than your typical IOPS. So this is something else to consider. Just wanted to give you an example. There's a company out there, a Modus, that's about to announce a new type of tiered SSD that they've put together. This is pretty interesting. They call it with gaming AI. And so basically what they've done is they have taken SLC storage and used that as a cache instead of expensive DRAM, and use that against a high density, high capacity QLC. So this gives you the performance and the capacity that you're looking for in gaming. And this is very important. Another thing that's really interesting is the software layer that they have put on the intelligent software layer that allows them to go back and forth and prioritize what should go in SLC storage and what should go in QLC storage is really important, because this intelligence is what makes it possible to maintain performance without going off the right cliff, because we all know with QLC, once you go off that right cliff, performance can be pretty bad. So in order to prevent getting to that right cliff, this intelligence makes sure that that happens. And so the data is intelligently moved back and forth between highly active storage and, you know, what's not so active. And like I said, we have seen this type of architecture for years in very expensive enterprise systems. So it's kind of nice to see this down into a commodity module that you can just pop into your gaming laptop or gaming workstation and be able to have that intelligence for yourself for your games. Just to show you some of the data performance, when you have a typical drive, what ends up happening is, you know, as the device is used, you can see that over time, you know, your performance is going to go down. The nice thing about having an SLC cache and having that intelligence built in is that you're able to maintain that performance for a very long period of time. And through, you know, remapping of high traffic areas, you know, your SLC can also maintain its performance as well. So this is something to think about. It's a different concept, a different idea. You know, is it the absolute fastest drive on the market? No, but is it a good performing drive that will keep the endurance and keep your gameplay up in a consistent level? Yeah, it will. This type of technology is something to think about. Another type of technology to think about is computational storage. Now, this started out as something that most enterprise architects are taking a look at for enterprise applications, but what they're finding quickly is things for applications for deep learning, gaming, other areas where it's not necessarily a server play, but it's also a workstation or, you know, a high-end performing mobile device. This can be possible. And the cool thing about this particular type of architecture is if we're looking at gaming, right here is where everything can be stored. So when you're loading the game, that game does not have to take up CPU cycles from the client. It can directly take care of that and do the decompression for you. So what does that do? That frees up your system to be able to handle that, you know, that texture detail and that real-time play, and be able to handle other parts of what you're doing with your game and the detail with your game and giving you that edge, instead of having to spend part of its cycles decompressing parts of your game. And so this gives you an edge in not only being able to do gaming locally, but also be able to do cloud gaming. And so, you know, this helps your device. Now, this not only helps your device, but this also on the infrastructure side, if you're looking at cloud gaming, this also helps cloud infrastructure as well, so that they can spend more time managing getting the data to you without having to worry about other things that could be getting in their way and making sure that you download that game as quickly as possible. Speaking of cloud architecture, let's take a look. Location. Location is a big deal. You know, because you have to realize that your console or your box is in the data center. That's where it lives. And you're just accessing that game. You're just accessing your console. And, you know, even Microsoft has a great way of allowing you to do this with your own Xbox if you're out of town. So whether you're doing that from your own Xbox or you're doing it from a data center. Google has deployed what they call gaming servers. These are dedicated gaming servers in a optimized data center with great GPU graphics, top of the line, getting you that edge on the pictures that you need and the movement that you need to keep up with. The other thing to think about with this changes also the dynamics of the workload. So now we have an on-demand workload. So this is going to be very similar to, the issues that you have to deal with, Netflix or, any other type of streaming service. Now you're dealing with compressed frames, you're dealing with speeds, frame speeds. So they all have to take this all into consideration because they're storing these games and feeding them to you on demand. So creators are changing how they create games because now that we have this new architecture and this new model, we have to pay attention to how we are streaming because it's a little different than if you've got the game locally or you're doing something from media because data is being constantly fetched, and especially if you're fetching texture, you really want to make sure that your memory doesn't run out and run over, because if you do, then you're going to start paging. If it gets worse, you're going to start thrashing onto your storage. And so what does your storage media look like when that happens? And so performance, you can lose up to 30%. Well, now you're no longer real-time gaming and you're getting behind your competitors, and you don't want that to happen. So looking at that, they're trying to look at improvements in race tracing to make these games more realistic, looking at the human factor, as I mentioned before about focus, how we focus, and making sure that that detail is there where we are focused and follow that. And compression, it comes back to another big deal. This is just an example. Google has this out there online on their architecture and their platform and how it looks. So as you can see, they've put together a pretty complex platform here for just dedicated gaming servers and making sure that they have the repository available to you to be able to stream just like on demand. And be able to stream to all your devices, not just your laptop, but be able to stream to your phone, any other type of devices that you have to offer. This is extremely important. So these games here, these game servers here, they're going to be able to take advantage of those same architectures with computational storage, with tiered storage. It's the same benefit on both sides. So it's not just for the data center and it's not just for the end user, but it's the whole package. The storage at the end of the day is going to be key, and the software intelligence around that and is what's going to make the difference between a good day of gaming and not such a good day of gaming. Data compression. You've heard me here talk about compression. Well, the source is compressed once, but the download and the decompression is many. So you want to make sure that you have a really good compression algorithm, because the better your compression algorithm is on the source, the less work that the decompression has to do at the other end. So that means your devices, your laptops, your workstations, even another server in your home. I know I have friends that have servers in their homes that they use for gaming. All of those need to be able to be efficient in how they do decompression. So less work on their end makes a more enjoyable experience. So that puts pressure on the cloud provider and on the game creators to make sure that they have the best compression algorithms out there. And there's other loading solutions that folks are looking at. They're looking at, like Microsoft, direct storage APIs. They're looking at dynamic loading and compression. How can they make those things directly available to game creators to make their experience a little easier and more efficient in how they create games? Also for the game user, the gamer themselves, to make their experience better. They're working really hard to overall to make that a better experience. Optimizing. They're always looking at ways to optimize, whether it's a error recovery flow, optimizing that, better garbage collection algorithms, because I'll tell you, if it does a flush or a checkpoint, your game freezes, nobody's going to be happy. So making sure that that garbage collection does not impact a game at all. And I'll tell you, it takes a talent. And that is something that was learned back in the enterprise when it came to enterprise databases. That was one big thing that they looked at when it came to checkpointing. It's the same kind of idea. Is your business going to stop because your database had to do a checkpoint? Well, it can't. If you're at a bank and you've got mission critical transactions going on, you can't wait for that. So looking at dynamic caching, right now it doesn't look as good for gaming as we would like, but I think that there will be some new things that are being rethought around dynamic caching that might make that possible. And also looking at reloading issues. That's another area that can be contentious when it comes to keeping that level of performance. And that is something that the storage industry is looking at as far as gaming is, what can they do to lessen the impact for reloading? And just to bring up memory, I know this is a storage topic, but memory is so important with gaming, and I just thought it would be important to bring this up because as we need more capacity in storage for gaming, demands for memory are going up. And this is something extremely important to pay attention to. And the reason why is because if you don't have enough memory, guess what? It has to go to storage. And the swapping and the thrashing will just take your performance down. It may freeze your system. So you always want to make sure that you have more memory than you need in order to prevent paging and swapping, and making sure that you've got enough space and memory, whether you're a creator creating a game at that level, or you're a user receiving the experience. You want to make sure that your memory management, how you handle memory, the amount of memory that you have is really important, because that will put less work on the storage. So 2020 is the year of the gamer, and there has been so many storage companies that have stepped up, coming out with all kinds of great new architectures to support gamers. There will be more to come. This is just getting started in this area. So hopefully this time next year, there'll be a lot more to talk about, but right now it's a really exciting time for the gamer in the storage industry. Please take a moment and rate the session, and your feedback matters. And I'd love to hear from you. So let me know. Have a great day, and thanks. Take care.